Okay, now in this lecture we will be discussing a numerical problem solving based on KVL. KVL is Kirchoff's voltage law. So here the problem is to determine V1, V2 and V3 in the given circuit diagram. So if you see here there are three loops. One loop is A, B, C, A, and second loop is A, C, D, A, and third loop is D, C, B. Right, so we have to apply KVL in these loops because they asked us to determine voltages V1, V2 and V3. So if you apply KVL in loop 1, the equation we will get is that if you start from A, from the point A, if you start, so what you are seeing first, you are seeing minus polarity first. So I'm starting with minus 24. Then in the same direction, once this voltage source is done, then we need to go for the resistor part in that loop, that is the branch of BC. So there the voltage across BC branch is plus V1. So while traveling in the clockwise direction, I'm seeing plus first, so then plus V1, then again while traveling in the same clockwise direction in the same loop, I'm seeing minus first for V2. So it is minus V2 equals to 0. So this is nothing but sum of the voltages within a loop is equal to 0. It is actually algebraic sum. Otherwise it is voltage, sum of the voltage rises is equal to sum of the voltage drops. So if you simplify this equation, you will get V1 minus V2 is equal to 24. Then similarly we can apply the loop equations in loop 2 as well as loop 3. So in loop 2, that is A, C, D, A, what you see, if you start from A, then to C, then D. So AC branch is the first one. There I am seeing in the clockwise direction of the current plus symbol first. So I am writing plus V2. Then for the branch of CD, I am seeing plus V3. Then I am writing plus V3. Then afterwards I am seeing plus. Here it is 12 volts. Right. Sorry, this 12 volts is not given. So we can write it here. This is 12 volts. Fine. Right. So equals to 0. Then with this, if you simplify this, you will get V2 plus V3 is equal to minus 12. Right. Then we got another loop. If you write KVL equation for that loop, that is DCD, so which is having only two components. So if I travel in the clockwise direction, I'm saying minus first, so it is minus V3, then again plus 10 volts, plus 10 is equal to 0. So you will be getting V3 is equal to 10 volts or 10 without units. So now in order to get V2 and V1, what we need to do, first we will be substituting V3 in second equation, which is the loop equation of loop 2 or KVL equation of loop 2. Then you will be getting V2 is equal to minus 22 volts, and if you further substitute V2 in equation 1, you will be getting V1 is equal to 2 volts. So in this manner you can solve any circuit using KVL. So here we have not used any current equation or current term because all the variables are directly mentioned in voltages. So no need to worry about currents and all because KVL includes only voltages. No need to worry about currents when we have only voltages given in the circuit. It is very easy, right? That's it. Thank you.